Now in this example, we want to use a triple integral to find volume again, but this time for a surface that's a bit trickier to deal with than a tetrahedron. So we have the surface that's bounded by z equals the square root of y, z equals y, x equals 0, and x equals 5. All right, so I graphed that in Maple for us to take a look at. All right, so it looks like this. So z equals the square root of y and z equals y are these two pieces, where z equals the square root of y comes across like that in an angle, and then z equals y is a diagonal line, right? Well, diagonal plane, right? And plot 3D, of course, is z equals automatically. If I do an implicit plot 3D, then I have to type them in as z equals and z equals, and sure enough, it's the same thing. Okay, so now we have to draw that on our paper. So that'll be fun. All right, so we have x, or excuse me, z right here, y right here, and then x comes out like this. And of course, part of it's pretty easy because it's z equals y, which is just, sticking straight out. So that's no problem. It's the curved bit that you have to kind of arc over, right? And then connect them. Okay, so which way are we going to orient ourselves here? So we know that the function was given to us in terms of z equals square root of y and z equals y. So that would speak to the YZ plane being a great choice, right? Because of these pieces right here, right? We're kind of giving the functions that we'll need for the YZ plane to be our region. So that's exactly what we're going to do. We're going to let the YZ plane, so let me draw it right here. So this is the surface right here. And then the region of integration on the YZ plane, so here's Z, here's Y, looks like this, or something like that. Okay, so we have Z equals Y is this piece right here, and then we have Z equals the square root of Y as the other piece. There, and I just kind of drew them in here. So Z equals Y is that plane, right, which is kind of aqua in my graph, and then it forms this line against this back wall, this YZ plane. And Z equals the square root of Y is this kind of curved arch kind of a thing, and that's forming this piece right here. Well, it's forming all of it. Okay, so then this is my region, right? So that was the surface. So this is the region of integration right here. All right, so let's set up our integral. So volume equals the triple integral and of 1, and then we have dx, dy, dz, or dx, dz, dy. Or we could put x in back. It doesn't really matter because x is going to be constant, right? X is going from 0 to 5. So if we want, we could put x in back. It's not hurting anything. So x is going from 0 to 5. All right, so then we'll do dz, dy, dx. I had to choose some colors here. dy, dx. Oh, I don't want to use that blue. 1 second. There we go. I made it a darker blue. Okay. Dz, dy, dx. And of course my x is orange, so I already fixed that. So x is from 0 to 5. Okay, so now z is going to have to get figured out because I have to go from the bottom to the top. So if I do dz dy, then I'm doing a vertical rectangle here, right? So dz dy would be like this. And again, you don't have to do vertical if you don't want to. You could do horizontal and do dy dz. It doesn't really make a ton of difference, but it's just usually trickier that way because we already have z solved for, right? So that's why we did it this way. Okay, so y is going to go from here, which is 0, to here, where they meet. So we ask ourselves, where's the intersection? Where do these two curves meet up? So that would be, where is the square root of y equal to y? That's where y squared, oh, well, y equals y squared. I'm squaring both sides. So y equals y squared. So y squared minus y equals 0, y times y minus 1 equals 0, y equals 0, and y equals 1. So all of that is a long-winded way to say y equals 1, right? 0 and 1. Okay, so y is going from 0 to 1. Now what about z? Okay, so the bottom of the rectangle is z equals y. The top is the square root of y. If you think about a column stacked inside, right, its bottom would be touching that aqua plane of z equals y, and the top of it would be hitting the curved surface of z equals the square root of y. So this is the bottom, and if you like, you can say z equals, just to remind yourself, and this is the top, z equals, right, top, bottom. Okay, so from there, we just integrate and we're all set. Right, the setup is where all the real work is on one of these. All right, so volume equals, I'm just going to segment this off so we don't get confused. Right, this was work on the side. All right, so the volume is equal to the integral from 0 to 5, and then the integral from 0 to 1. Oh, actually, I take it back. We can use our trick. Let's just look at this for a second. There's no 5, there's no x, anywhere in here, right? So let's look. There's no x in the integrand. There's no x in here. So there's no x. So we can use the trick. The x can go away and become 5, right? If you integrated this with respect to x, it'd just be x. X goes from 0 to 5. So that's 5 take away 0, which is 5. So you just put a 5 out in front. And now you have the integral from 0 to 1. And then I can integrate 1 with respect to z. It'll be z from z equals y to z equals the square root of y, dy. All right, so that's 5 times the integral from 0 to 1, and that would be the square root of y, take away y, dy. This particular one is, well, quite frankly, very easy, right? So, but we can find it with Maple if we want. But we should be able to do that integral, right? 3 halves y squared, 3 halves y to the, or y to the 3 halves times 2/3, that's what it is. And then minus 1 half y squared. So that's, if I put 1 into that, that's 2/3, take away a half, 2/3 take away a half is 1/6, so this would be 5/6. So I could do this by hand. I didn't need Maple. I take it back. So it's easy enough. Of course, I can always check myself with Maple if I needed to. Now, if I said that x, y, z are in centimeters, right, then this would be centimeters cubed because I'm finding volume down here. Now let's go double check ourselves with Maple. Even if we do it by hand, it never hurts to check. And there we go. Sure enough, the original integral and then those integrals, it's all good. It's 5/6. Oops, I pressed the wrong button. 1 second. All right, there we go. So the answer is 5/6, in this case, centimeters cubed.